Hi guys, today we're going to be learning about how to solve one-step equations. Okay, and solving one-step equations is probably something that you have worked on last year. However, we're going to review it before we begin two-step equations after our mastery test. Okay, so when solving a one-step equation, we want the equation to be balanced. Okay, we use the inverse or opposite operation, to solve the equation. Okay, so the inverse of each of these is what would undo it. Okay, the opposite or inverse of addition is subtraction. Right. The inverse or opposite of subtraction is addition. So these two are kind of paired up. One is the opposite of each other. And multiplication are similarly inverses of each other. Multiplication, the opposite or inverse of multiplication is division. And the inverse or opposite of division is multiplication. So we call these one-step equations because in order to figure out what x is, it only takes one step or one operation for us to solve. Okay? So our goal in an equation, you can tell it's an equation, it's got an equal sign. Our goal is to figure out what x is. Now, you'll notice these examples are pretty straightforward. Just by looking at it, you can probably figure out that some number plus 3 is equal to 4. That number x probably has to be 1, right? But the goal in this is not just to get the correct answer. The goal is in actuality to identify the inverses and use the correct form. Because later, when we get into much more complicated equations, you're going to want to use this methodology that we're teaching you on an easier example. Otherwise, you're not going to be able to solve. So the expectation is that not only will you be able to tell what x is, but you're able to set up the problem the way that I'm showing you. Okay? So in an equation, we have to have the left side equal to the right side. And the rules of the equation game are you can change the equation, but you have to change both sides. Otherwise, it will not stay balanced. Okay? And in order for us to solve for x, right, to figure out what x is, we want to get the x alone, right? So our variable is right here. In this case, it's x. And what's keeping it from being by itself is this plus 3. So our operation that we want to undo is addition. What is the opposite of addition? It is subtraction. So if I'm adding 3, the opposite of adding 3 is subtracting 3. Now I can subtract 3 from the equation, but I have to do it to the expression on the left and the expression on the right. I have to do it on both sides. That's why it's important to draw a line down the middle so you know, okay, if I do something here, I need to have the exact same thing on this side. Now I'm going to draw a line, and just like you used to draw a line and bring down the answer when you were in elementary school, we're going to do that here. Okay, this is x, okay, and then positive 3, take 3 away gives you 0, right? Plus 0. And then over here, 4 minus 3 gives us 1. Now, do we have to write a plus 0? No, it's unnecessary. We don't write plus 0 because it's just the same as the thing of itself. So we're just going to cancel. We don't need to write that. And instead, we just write the x by itself, bring down our equal sign. X is equal to 1. Okay. Perfect. Now, if we wanted to check this, we could evaluate it by substituting back in. If I have x plus 3 equals 4, I can evaluate by substituting into parentheses for x. We figured out that x is equal to 1, so when we put a 1 in there, we get 1 plus 3 is 4. 4 is equal to 4, so we know this is correct. All right, let's try the next one. First thing we do Draw a line, put a box around our variable. Now what's the operation that is being done to x? What are we doing to the x? Here we are subtracting 9. The opposite of subtraction should be addition. So to cancel it out, to get it by itself, if we have minus 9, plus 9 will get it back to 0. But if we do it to the left, we have to do it to the right. Then we bring our line, and we bring down what's left. We have an x on this side, and then we'd also have a 0. These cancel out. Plus 0, which we don't have to write. And then negative 22 plus 9. Okay, that should give us a negative 13. You can use Desmos for parts like this, negative 22 plus 9, if you would like help with the integers. All right, now let's take a look at multiplication and division. Remember that when you have a number right next to a variable, it is multiplication. So even though you see a negative sign, this is actually negative 7 times y, because what we're looking for is what is in between the number and the variable. Here, number and variable, there's a plus in between. Here, number, variable, there's a minus in between. Here, number, variable, nothing in between. I drew in a dot to remind myself, but nothing in between. So if there's not a sign in between, it is multiplication. If that's the case, I usually put a dot in just to help me remember. The opposite of times negative 7 would be to divide. Dividing by negative 7. And we're going to divide by negative 7 on both sides. Just like we did above, we draw a line down. Negative 7 divided by negative 7, anything divided by itself is 1. So we have a 1 times y equals 56 divided by negative 7 is negative 8. But do we need to write 1y? No, we assume if we write a y down there, there's at least one of them. So we don't ever really write a 1 as a coefficient. Instead, we just write it by itself, y equals negative 8. Okay, last one on this page, we have a. And what's happening to a? It's being divided by 6. All right, we can see that the operation being done to the variable is division. So the opposite of division is multiplication. Right? Opposite of dividing by 6 is times 6. But of course, we have to do the same thing to both sides. Then draw our line. That will cancel it out. And we end up with just a on this side. So we know that a has to be equal to negative 24. And again, we can substitute in by evaluating if we want to check. A divided by 6 should be equal to negative 4. We figured out that a was equal to negative 24. So let's substitute that into parentheses. Divided by 6 equals negative 4. Is negative 24 divided by 6 equal to negative 4? Oh, it's not. Oh no, I just forgot a negative. I put a negative where it didn't belong. Is negative 24 divided by positive 6 negative 4? Yes, it is. So negative 4 equals negative 4, and we're in good shape. All right, let's try some problems on the back and see how you do. Go ahead and try problems 1 and 2 by yourself, and then we'll check them together. Okay, so looking at the first two problems, you should have it set up the same way that I did. You box the variable, and you draw a line down the middle. Now, if you look, you can see that what is being done to k, that is keeping it from being alone on the left side, is that we have added 10. The opposite of adding 10 is minus 10. So make sure you did that to both sides. This cancels out, and now you just have the k left, which we bring down. And on the right, 18 minus 10 is equal to should be an 8. 18 minus 10 is equal to 8. To check that, we set up our problem, put in parentheses, and substitute in the answer that we got of 8. If k is 8, then 8 plus 10 is 18, and our two sides are equal, so we know we did it right. The next problem, n minus 5, the opposite would be plus 5, which we do to both sides, don't forget. That cancels out and leaves the n alone on this side and is now equal to negative 8 plus 5 is negative 3. If I substitute that answer of negative 3 into parentheses and check my work, negative 3 minus 8 is negative 8, which does in fact equal negative 8, and we're in good shape. Ooh, excuse me. Go ahead and try the next two problems. Actually, try the next three problems. Try 3, 4, and 5 on your own, and we'll see how you do. Okay, so for the first problem, you'll notice there's nothing, no sign or operation symbol in between the 7 and the y. They're right next to each other. That means it's multiplication. So to cancel that out, we would have to divide by 7 on both sides. That gives us y is equal to 49 divided by 7, or negative 49 divided by 7 is negative 7, which, when we substitute back in, is equal to negative 49. So we know that our answer is correct. For this one, we see that d is being divided by negative 3. The opposite or inverse of division is multiplication. So we're going to multiply by negative 3 on both sides. That cancels out the division, leaving us with just d on the left, and on the right, leaving us with negative 45. If we substitute this in for our variable to check our work, which you should be doing as well, then we get that 15 is equal to 15. Last one, again, this is the tricky one where you see a negative sign, but it's not in between the 3 and the n. There's nothing, no operation between the two of them, so we know this is actually multiplication. You may have been tempted to do plus 3, but you're actually doing the inverse of multiplying. The opposite of multiplying is dividing by negative 3, which should give us n is equal to negative 2, which when we check our work is equal to 6, giving us the correct answer. Now you're going to practice some examples of each of these types of problems, and following that you're going to do some review for your master exam, which will be next class. Speak with you soon.